Hi guys, today let us do a quick revision of the third module. First, here we studied about the internal combustion engines. These are the engines in which the combustion of fuel takes place inside the engine cylinder. Well, the IC engines are classified based on the type of fuel used into petrol engines, diesel engines, gas engines and biofuel engines according to the method of ignition into spark ignition where a spark plug is used to ignite the fuel and compression ignition engine where compressed air is used for the ignition according to the number of strokes per cycle, that is a 4-stroke engine where 4 different strokes are required to complete one working cycle, 2-stroke engine where 2 different strokes are required to complete one working cycle. According to the cycle of combustion, they are classified into Otto cycle where combustion of fuel takes place at constant volume, diesel cycle where the combustion of fuel takes place at constant pressure, and dual combustion cycle where combustion of fuel first takes place partially at constant volume and then at constant pressure. They are classified according to the number of cylinders used into single cylinder engine and multi-cylinder engine. Also, they are classified according to the arrangement of cylinders into vertical engine where the cylinders are arranged in vertical position, horizontal engine where the cylinder is arranged in horizontal position, inline engine where the cylinders are arranged in a line, radial engine where the cylinders are arranged along the circumference of a circle, V engine which is a combination of two inline engines equally set at an angle, and then opposite type engine where the cylinders are arranged opposite to each other. They are also classified according to the method of cooling into air-cooled engines where air is used to cool the cylinder walls and water-cooled engines where water is circulated to cool the cylinder. They are also classified according to their uses into stationary engine, automobile engine, marine engine and aircraft engine. Next, we studied the different parts of the IC engine, that is the cylinder, which is a cylindrical shaped component where the combustion of fuel takes place, cylinder head, which is a removable component which is present in the top portion of the cylinder containing the inlet exhaust valves and other components like spark plug or fuel injector, piston, which is a cylindrical shaped component which fits perfectly inside the cylinder used to compress the fuel and also receive the impulse force produced by the combustion of the fuel, piston rings, which are used to maintain a tight seal between the piston and the cylinder, the connecting rod, which forms a link between the piston and the crankshaft, the crank, which is a lever connected to the lower end of the connecting rod and the crankshaft, which is used to transmit power developed by the engine to drive the vehicle, the crankcase, which is the lower part of the cylinder block which encloses the crankshaft, and also the flywheel, which is a large disc or wheel mounted on the crankshaft which stores rotational energy, and then the engine valves, which is the inlet and exhaust valve, which is used for the entry of fresh air or fuel and also for the exit of the burnt gases. Then we looked into the IC engine terminologies such as the bore, which is the inner diameter of the cylinder, the top dead center, which is the extreme position of the piston near to the cylinder head, the bottom dead center, which is the extreme position of the piston near the crankshaft, the stroke, which is the linear distance traveled by the piston when it moves from the TDC to BDC, the stroke volume, which is the volume swept by the piston when it moves from TDC to BDC, the clearance volume, which is the volume of the cylinder above the top of the piston when the piston is at TDC, the compression ratio, which is the ratio of the total cylinder volume to the clearance volume, the piston speed, which is the average speed of the piston as it moves from the TDC to BDC, which is given by 2 into Ln, the mean effective pressure, which is the average pressure acting on the piston throughout the power stroke, which is given by Pm is equal to Sa by L, the indicated power, which is the total power developed inside the engine cylinder due to the combustion of fuel, which is given by N Pm Lank into 10 by 6, the brake power, which is the net power available at the crankshaft of the engine for performing useful work, which is given by 2 pi nt divided by 60 into 1000, the frictional power, which is the amount of power lost due to the friction of the various moving parts, which can be given by Ip minus Vp, the mechanical efficiency, which is the ratio of brake power to the indicated power, the thermal efficiency, which is the ratio of the power output to the heat supplied, and then the specific fuel consumption, which is the amount of fuel needed to provide the given power for a given time period. Hence, this can be given in terms of indicated power and brake power, that is, ISFC is the fuel consumed divided by the indicated power and BSFC is the fuel consumed divided by the brake power. Then we studied about the construction and working of a 4-stroke engine. Well, the 4-stroke engine will have 4 strokes, that is the suction stroke, where the exit valve is closed and inlet valve is open, and hence a fresh mixture of fuel and air will enter the cylinder. The compression stroke, where both the valves are closed and the piston will move from the BDC to the TDC, hence compressing fuel. Power stroke, in which the fuel is burnt by either using a spark plug in case of a petrol engine and a fuel injector in case of diesel engine, as a result of which the burned gases create a small explosion, which results in the rapid movement of the piston from the TDC to BDC and hence rotating the shaft. And then the exhaust stroke, in which the inlet valve is closed and the exhaust valve is open to let go of the waste gases produced as a result of combustion. The cycle is repeated continuously in order to produce power. We also plotted the PV diagram for the process. Then we studied the construction and working of a 2-stroke engine, in which there were 2 strokes, that is the downward stroke, which resulted in the entry of fresh mixture of air and fuel into the cylinder, and also the transfer of this mixture into the cylinder head through the opening of the transfer port, and then the combustion of the fuel using a spark plug, and then the upward stroke, during which the piston moved from the BDC to DDC, hence forcing out the combustion gases and the used mixture outside of the cylinder. Then we studied about the numericals based on the concept and calculations for IC engines. Then we moved on to the concept of refrigeration. Well, refrigeration is the process of reducing the temperature of a given space below that of the surrounding and maintaining this low temperature within the boundary of the given space. The refrigerating effect is nothing but the amount of cooling produced by the refrigeration process. Ton of refrigeration is the capacity of the refrigerator, that is the amount of heat absorbed in order to produce 1 ton of ice in 24 hours from water whose initial temperature is 0 degrees. Hence 1 torr can be given as 3.5 kilowatts. Next, the ice making capacity is the capacity of a refrigerating system to remove heat from water to make ice. The coefficient of performance is defined as the ratio of the amount of heat removed from the given space to the work supplied for the heat removal, that is COP is nothing but Q by W. Also, the relative COP is nothing but the ratio of actual COP to the theoretical COP. Then we studied about the refrigerants. Well, refrigerant is a chemical substance which absorbs heat from the substance and rejects this heat and hence keeps the substance cool. Then we studied about the properties of the different types of refrigerants such as ammonia, sulfur dioxide, carbon dioxide, freons such as R12, R22 and then HFCs. Well, we studied several properties of the refrigerant such as the thermodynamic properties, which included low boiling and low freezing point, high latent heat of vaporization and high critical temperature, physical properties such as low viscosity, low liquid specific heat, low specific volume, high thermal conductivity and high electric insulation, chemical properties such as non-toxic, non-flammable, non-corrosive and good chemical stability and miscibility with the lubricating oil, and also other properties such as availability, cost, ease of handling and impact to the environment. Then we studied about the working of a vapor compression refrigerator, where a liquid refrigerant passes through the evaporator and absorbs the heat inside the cabinet, goes into the compressor where it is compressed to high pressure and temperature, then passes through the condenser where it is condensed into liquid state and hence gives away the absorbed heat into the cooling medium, and then again passes through the expansion valve where it is expanded back to low temperature and low pressure liquid refrigerant. The cycle continues in order to keep the substance cool. Similarly, we studied about the working and construction of a vapor absorption refrigerator, where the liquid refrigerant passes through the evaporator, absorbs the heat from the substance, then passes into the absorber where it is mixed with a solution of the same refrigerant composition, then pumped into a heat exchanger where it gets heated into high pressure and high temperature, then passed through the generator where it is heated and hence the liquid vapor and the gaseous vapor get separated, where the liquid vapor is sent back to the absorber and the vapor refrigerant is sent to the condenser where it is condensed to a liquid state and hence gives away its heat energy, and then made to pass through the expansion valve where it is expanded back into low temperature and low pressure liquid refrigerant. The cycle continues in order to keep the substance cool. Then we studied about air conditioning. Well, air conditioning is the process of simultaneous control of temperature, humidity and cleanliness of air motion in a confined space. Then we studied about the construction and working of a room split air conditioner. Well, here it works in a VCR cycle. Well, the blower draws the warm air through the air filter and this warm air is cooled by a liquid refrigerator which is then supplied to the room as cold air. The cold air mixes with the air of the room and hence makes the room cool by bringing down the humidity. Well, the refrigerant which absorbed the heat from the warm air now flows through the compressor where it is compressed and then enters the condenser where it is cooled into liquid state. The fan draws and blows the atmospheric air over the condenser coils and hence the heat is now given away into the atmosphere. Now the refrigerant enters the expansion valve and is expanded back into a low pressure and low temperature liquid refrigerant. The same cycle is repeated in order to keep the room cool. Then we studied about the applications of air conditioning for comfort applications in residential buildings, institutional buildings, commercial buildings and in transportation, and also for process applications in hospitals, in nuclear power plants, in printing factories, in textile factories and in food processing centers. Thank you.
Wow, that's impressive! You have completed a magic today. For more videos, subscribe. Join our Facebook group and Instagram page for group discussion and live magazine videos for exam preparation in an hour. We start at ClassFly community for students to learn from a friend in a simple way and support them in their own languages. If you are willing to be that one friend who saves us at the exam night preparation, then please join us by visiting classfly.in.